Hello, thank you for checking out A1 Math, and today we're talking about converting a rhythmic sequence into function notation and also geometric sequence into function notation. So let's take a look and see what we got. Now, here are your steps for converting an arithmetic sequence to function notation. Okay, so the first thing you want to do is change the a sub n to f of n. You want to distribute the d, and then you want to add all constants. And the constants will be your numbers that doesn't have the variables in it. All right, here's our first example here. All right, now here we're going to do the first step, which is change a sub n to f of n. And then we're going to distribute the negative 9 over 4 to the n and negative 1. So this will be distribute like so. All right. And then once we do that, we'll end up with a negative 9 over 4n plus 9 over 4. So we're going to bring down the 4, distribute the negative 9 over 4 times n to get us negative 9 over 4n. And then negative 9 over 4 times negative 1 to get us a positive 9 over 4. Okay, and that's our second step. Now, our third step is to add our constants, which is going to be 4 plus 9 over 4. All right, so I'm going to bring down the negative 9 over 4n here and combine 4 plus 9 over 4. If you have a graphing calculator, you could just type that in 4 plus open parentheses 9 divided by 4 close parentheses. Okay, and that's a first example here. Let me do another example. Now, on this example, we're going to follow the same steps. The first step is to change this a sub n to f of n. Okay, so you have f of n like this. The next step is you want to distribute the 4 or the d to each term over here in the parentheses. So you'll have 4 times n, which will be 4n, and 4 times negative 1, which would be negative 4. So now we're going to bring down the negative 20 plus 4n minus 4. Now our next step is to combine or add the constants in this here, which are going to be negative 20 plus negative 4. Okay, so now we've got 4n minus 24. Now, now our equation looks like y equals mx plus b, with the 9 over 4 being the slope, but your plus b will be 25 over 4. And over here, 4 is your slope, negative 4 is your b. Okay, and that's how we convert a arithmetic sequence into a function notation. Now I'm going to show you how to convert a geometric sequence into a function notation. Okay, so on this one, as you can see, the steps are very similar. So for the steps for converting a geometric sequence to function notation is change the g sub n to f of n. We're going to distribute the r. Now, it's not really distribution, it's the power rule with your exponents, but it looks like distribution. So I'm going to show you that. And then we're going to multiply all the constants. Okay, so this r, we're going to separate it using the power rule and then multiply all the constants. Let's take a look at an example. Okay, so here we've got a geometric sequence. I'm going to do our first step, which is change the g sub n to f of n. Then our next step is going to quote unquote distribute or use the power rule. So I'm going to bring down the -2 and distribute this 3. So the 3 is raised to the n and the 3 is raised to the -1. So now I've got -2 times 3 to the n times 3 to the -1. Okay. Now our third step is to multiply the constants. So our constants here is -2 times 3 to the -1. Now if you have a graphing calculator, you could type it right in from here. But if you do not, you want to convert this into a fraction and just multiply those. So let me show you how that looks. You have -2 over 1, and it's 3 to the -1 is the same as 1/3. And I'm going to put this multiplication of 3 to the n power on the outside here. Okay. Finally, I'm going to go ahead and multiply this fraction, and I get -2 over 3 times 3 to the n. Now remember, if you type this straight into a graphing calculator, don't forget to hit math and fraction to see if you get a regular proper fraction here. Okay, let me do another example. Okay, so again, we're going to start by changing the g sub n to f of n. Next, we're going to distribute with the power rule this zero point 0.1 raised to the n and then zero point 0.1 raised to the -1. Okay, and that's going to get us 1,234 times 0.1 raised to the n times 0.1 raised to the -1. And then our third step is to multiply the constants. So our constants is 1,234 times 0.1 raised to the -1. And again, you could type this straight into your calculator and get your answer. But also you can convert this into a fraction like so. Multiply across the numerator and denominator. And then divide the 1,234 by 0.1. And you get 12,340 times 0.1 raised to the n. Now we've got to convert it into function notation from here. So to recap, we've got converting a rhythmic sequence uh, to a function notation with our steps to change the a sub n to f of n, distribute the d, and add all the constants. And 2, we have steps for converting a geometric sequence to a function notation, change g sub n to f of n, distribute the r, and then multiply all the constants. Here's a couple problems to practice with a rhythmic sequence, converting it to function notation. And the answers to check. Here's geometric. I'm sorry, we've done those. Here's 2 new ones. And you can check your answers here. Okay, and again, I want to thank you for checking out A1 Math. Have a nice day.